No thanks. Okay. A local coffee shop wants to determine if customers prefer the flavor of their cappuccino with oat milk or regular milk. They recruit a group of 40 volunteers for taste testing. They randomly assign half of them to drink a cappuccino with oat milk and then rate the flavor scale from 1 to 10. The other half drink a cappuccino with regular milk and then rate it on a scale from 1 to 10. Is this completely randomized or matched pair experiment? So did they pair? Right.
They randomly assign.
Okay, so they randomly assigned half of them, right? Okay. Define the parameter of interest for this experiment. What are they trying to find?
Cappuccino with regular over like no, it's one sample. It's one sample.
So the parameter is
Like this.
Yeah.
Yeah. So it'd be the true difference in the room
right.
between the two.
Yes. So you're going to say M1 minus M2, which is the true difference between the means of the flavor of the cappuccino. So oat milk minus, what was the other one? Regular milk? Yep. Good. All right, read part C. A local coffee shop wants to determine if customers prefer the flavor of their cappuccino with oat milk or regular milk. They recruit a group of 40 volunteers for taste testing. Each volunteer drinks one cappuccino with oat milk, then another with a regular milk, and order is randomized. They're asked to rate the flavor of each drink on the scale from 1 to 10. Is this completely randomized experiment or matched pairs? Matched pairs, because one person is doing both things and then having the influence there. Do we see the difference between A and C? In A, we split them up. They only drink 1 cup of coffee. In C, we say, hey, drink both and give us the rating. Yeah? Matched pairs. Good?
I'm good.
God bless. So instead of splitting your people in half and each group getting 1 coffee, I'm now getting each person to drink 2 cups of coffee to give me the ratings. Because, like, let's say you like sweet coffee and I like bitter coffee. Well, if I drink a cappuccino with oat milk, it's not going to be good to me, right? So that's going to be kind of like an influence. So you want to make sure that you're getting both sides, both groups from one person. Yes, no?
Yeah, in C they are.
In C.
Oh, in C they are.
Yeah, read that part. Good? Okay. Good.
This event's like why what has been done?
This is still 2 sample. It's still 2 sample. This would just suck as like a person who actually ran the experiment, because now I'm getting 30 people 2 times the coffee at 60 cups versus 30 cups with 15 each. Right. But running that experiment would suck, yes. Because you got to remember which one you gave them first. So, yeah. So be kind of like a hot mess. Now, define the parameter of interest for this experiment. This is going to be mu difference is equal to the true mean difference in ratings for the flavor of cappuccino. So instead of saying M1 minus M2, we're saying the true mean difference. So each person got 2 cups of coffee, right? You're going to give a rating for oat milk and then the other one. You'll find the difference. That's 1. Yes? Does that make sense? Okay. Good.
It's doing what this is possible before or after.
Before.
Yeah.
Okay. Good. So we know the difference. Yes, no, maybe. Okay, not the maybe.
Like you're like you get like 5 or like something where it's like you just have someone recognizing us.
Yeah. Once we've